Today in Capechi's Corner, we're going to work with factoring trinomials, and this is day 1. When we're asked to factor, we're asked to break down a trinomial, usually into two binomials. The first thing we always have to do is look for a greatest common factor. And remember, a greatest common factor is a number which goes into each term or a variable which goes into each term. So in looking at number 1, we do not have a greatest common factor. There isn't a variable or a number that goes into all three terms. So when we're looking to factor, the first thing I'd like to do once we realize that we don't have a greatest common factor is just set up our two binomials. The first place we look is our second sign. Because that's a plus, it tells us that our signs are the same. So they're either both plus or both minus. Now, we know if they're both plus or both minus by looking at the first sign. Because my first sign is a plus, I know that both my signs are going to be a plus. Now, the only way I can get to y squared is y and y. Now, when you're factoring, you're actually doing the opposite of FOIL. So I know y times y gives me y squared. Now I need to figure out what numbers I need to go into my other parts of my binomial. So I need factors of 27, which would be 27 and 1, or 9 and 3, that when I add together, I get 12y in my middle term. That will be 9 and 3. Now the great thing about factoring is that I can use FOIL when I'm done to check my answers. So I have y times y gives me y squared. My outside term is plus 3y. My inside term is plus 9y. And my last term is 27. Now when I combine my like terms, I'm left with y squared plus 12y plus 27, which is what I started with. So I know in this step right here that I factored correctly. Now in number 2, again, I'm always looking for my greatest common factor, and I notice that 2 goes into each term. So I'm going to divide everything by 2, and when I do that, I'm going to write that out front. So I'm left with x squared plus 3x plus 2. Now from here, I'm ready to factor. So I'm going to set up my two binomials. And I look at my second sign's a plus, so I know that my signs are the same. They're both a plus because that first sign's a plus. I know the only way I can get to x squared is x and x. And factors of 2 are only 2 and 1, and I'm looking for something that combines and gives me a 3, which 2 and 1 does. Now again, if I want to check my work, I'm just going to leave my 2 out front, and I'm going to use FOIL on my two binomials. That gives me x squared plus my outside is x, my inside is 2x, and my last is 2. So again, I'm going to bring down this 2, and I'm left with x squared plus 3x plus 2. Now my last step is to distribute through this 2 right here. So I'm left with 2x squared plus 6x plus 4, which is exactly what I started with, so I know I factored correctly. In looking at number 3, we do not have a greatest common factor, so we'll set up our binomials. Our second sign is a plus, so that means our signs are the same, but this time our first sign's a minus, so that means both signs are a minus. So the only way to get to b squared is b and b. Now I'm looking for factors of 6. That gives me either 6 or 1 as an option, or 3 and 2. And because the signs are the same, I'm looking at factors of 6 that add to 5, which is going to be 3 and 2. Now because of the signs are the same, it does not matter which binomial I place the 3 and the 2. Now again, we'll check using FOIL. So I get b squared, my outside is 2b, my inside is 3b, and my last is 6. So when I add them together, I get b squared minus 5b plus 6, which is what I started with. So I know my answer is okay. Now number 4 again, my greatest common factor here, although I don't have a number that goes into all three terms, if I'm looking at my three terms, they all have at least an x to the second. So I'm going to take my lowest power, x to the second, because I have x to the second, x to the third, and x to the fourth. I'm going to divide everything by x to the second. I'm going to write my x to the second out front. Now I'm left with x to the second minus 15x plus 56. Again, I'll bring down my x to the second, and now I'm ready to factor. My signs are the same. They're both a negative. The only way I'm going to get to x squared is x and x. Now factors of 56. Although there are a lot, only 7 and 8 are going to work. Factors of 56 that when I add, I get to 15. So I'll put 7 and 8 there. So now again, I can check it. I'll rewrite my x to the second. I'll use FOIL. I get x to the second minus 8x minus 7x plus 56. combine my terms, and I have x to the second minus 15x plus 56. In my last step, when I'm checking, I'm going to distribute that x to the second, and I get x to the fourth minus 15x to the third plus 56x to the second, which matches what I started with, so I know that I factored correctly. In number 5, first I look for a greatest common factor, which there is none, and then I notice something different this time. My second sign here is a negative, which we haven't done yet. So I'm still going to set up my two binomials. And I notice that my second sign is a negative, so I know I'm going to have opposite signs, one of each, a plus and a minus, doesn't matter where you put it. And I notice again that I have a j squared, so the only way I can get to j squared is j and j. Now this time, because my signs are opposite, I need to find factors of 40 that when I subtract, I get to 3. So again, I have a lot of options. I have 40 and 1, 20 and 2, 10 and 4, 8 and 5. And I notice that 8 and 5, when I subtract them, I do get 3. Now, because I have a plus and a minus, this time it does matter where I put the 8 and the 5. Now, I notice that my first sign is a plus, so that means my higher factor has to be attached to the plus. So my higher factor in this case is 8. So I'll put my 8 there and my 5 there. Now, when I check it, it shows you why it turns out that way. So let's use FOIL. I have j times j gives me j squared. My outside term is negative 5j. My inside term is positive 8j. And my last term is negative 40. Now, when I combine my terms, I get j squared plus 3j minus 40, which is what I started with. Now, because with my outside and my inside term, because I have opposite signs, when I add them, that's why it's really important that I'm looking for something when I subtract, I get there. Because I'm not going to add 5 and 8 and get 13. I have negative 5 plus 8, which is going to give me a positive 3. That is why it's also important that the higher factor is attached to the first sign of my trinomial. And looking at our last problem for today, number 6, again, I'm looking for my greatest common factor. In this case, a 5 goes in each term, and also an f to the 5th. That's my lowest exponent. So I'm going to divide everything by 5, f to the 5th, since that's my greatest common factor, and I'll rewrite that out front. And I'm left with f to the second minus 2f minus 8. Now again, from here I'm going to factor, so I'm going to rewrite my 5f to the 5th. Have my two binomials. Again, I notice that my sign is a negative, so it means I'm going to have a plus or a minus. So I'm going to have one of each. And I'm looking for factors of 8. So I have 8 and 1, and I have 4 and 2. Because my signs are opposite, I'm looking for factors of 8 that I subtract, I get to my middle term, which is 2. So that's going to be this 4 and 2. Now the other thing, again, I have to be careful of, my first sign there is a negative, so my higher factor has to be attached to the negative, which will be 4. So 4 is going to go here, 2 is going to go there. The only way I'm going to get to f squared is f and f. Now I can check my work. So I'm going to rewrite 5f to the 5th. I'll use FOIL. I have f squared minus 4f plus 2f minus 8. Again, combine my like terms. Then I have f squared minus 2f minus 8. And my last step, again, I'll distribute through that 5f to the 5th, which gives me 5f to the 7th minus 10f to the 6th minus 40f to the 5th, which is what I started with, so I know I factored correctly.